guys, we're looking at two different Delta Math types of questions. The first one that you'll have in your assignment today is the parallelogram properties with angles. Now, this is called a quadrilateral. A quadrilateral is a shape with four sides. Right? Triangle has three sides. We've spent most of the time looking at triangles this year, but I want to make sure you're familiar with some of the other shapes before they leave. So we do have quadrilaterals, which have four sides. Now, a parallelogram is a specific type of quadrilateral where where sides that are across from each other are parallel to each other. So right now, PQ is parallel to NR. PN is parallel to QR. You see that? What that does, if you remember when we studied parallel lines, we studied alternate interior angles, same side interior angles. We studied exterior angles, corresponding angles. If you look right here, when you compare this angle right here, so you can call it angle P, and you can compare it to angle Q. Now remember, in this, PN is parallel to QR. So if you have this line going across, and then the left and the right are parallel, angle P and angle Q right now are same side interior angles. And if you remember, same side interior angles are supplementary, meaning they add up to 180. The relationship would also exist with this line. If you use this line and take PQ to NR, they're parallel. So angle P would also be supplementary with angle N. So the way it works, I can take all this and break it down very simply. P is going to be supplementary with Q and with N. And P is going to be identical to R, as long as it's a parallelogram. It's not the case in every quadrilateral, but parallelograms. So supplementary means they add up to 180. So if you need to, you can just pull up a calculator for all of these. You just do 180 minus 125, and you get 55. So this is 55 degrees. This one over here would be 55 degrees, and this one over here would be 125 degrees. And there we go. Look at these, they're across from each other. That makes it even easier. Angles across from each other are going to be identical in a parallelogram. Right here, these will be supplementary. I don't even need to pull out the calculator. Hopefully you can do this in your head too. 180 minus 110, what's missing? That'll just be 70 degrees. So that's all we need to do. So for the first three questions, we're going to do that. All right. It is set up the way Delta always is, where if you get one wrong, you'll need to do an extra one. So make sure you take your time, do them right. And then the next thing we're going to do is diagonals. Now, the way that the diagonals work, the diagonals are exactly what they sound like. They're the segments that cut from one corner across to the other. And then this diagonal cuts from that corner over to the other. Now, what diagonals will do, they work out where they intersect, bisects both of them. So this point V where they intersect will cut this in half. So therefore, SV is exactly the same as VU. And SV is half of SU. VU is half of SU. And then same going across. RV will be the same as VT. And then RV and VT, they're both half of RT. So if US is 42, okay, so U all the way across to S, U all the way over to S is 42, find UV. Look at where UV is. That's just half of it. So what's half of 42? You can figure this out in your head, or if you need to do 42 divided by 2, to find half of it, it's 21. So it's 21, which makes sense, doesn't it? Because VU would be 21, SV would be 21, and they add up to 42. If JL is 32, J all the way across to L is 32, find JN. So again, we need to take half of 32, so 32 divided by 2, and we get 16. If KL is 16, find LH. KL is 16. What is LH? Remember, they're both going to be identical because they're two halves of the diagonal. So this will just be 16. If BE is 10, find ED. Again, same thing. All right, so you see, hopefully you find both to be simple. I just would like you guys to be familiar with some of these shapes and some of the relationships. So that's it for today. Do those two sets of questions, and that will be it. As always, email me if you have any questions or any issues logging into Delta.